enumerations. Now, before we get started, let's look at the meaning or the definition of enumerations. And before we jump upon how enumerations are handled in Swift, I'm just going to go over the Webster dictionary meaning of an enumeration. It's an act or process of making or stating a list of things one after another. So a bunch of items listed one after the other, like anchovies, jam, pickled cherries, blended grapes. All good. Or it's an act or process of counting something or a count made of something. All good. Now let's see how does that applies in Swift or in computer programming, and why did the word enumeration was chosen for this particular data type. For this, we'll revert back to our examples, and we're going to first go over the problem which we're trying to solve when we're doing switch case statements. And in this, we have done that inside a function, and we have a function named calculate. And in this example, we are hypothetically building a calculator application. And the calculator is supposed to calculate based upon the two parameters passed to it and the operand, decide whether it's doing the addition, multiplication, subtraction, or division. So one of those four operations. The way we implement it is that we define a function, calculate, makes sense. It takes the first parameter and the second parameter. Okay, both are type double. You can have integers, you can pass doubles, whatever you like, and an operator, because someone needs to tell us whether you're trying to do addition, subtraction, multiplication, or division. And you could say that, okay, we could have four different methods, one for each of these operations, but then also someone who is calling them needs to know what operation is being performed. So somewhere there's an operation being done. So all good and dandy, but I have a problem. The problem is that with the switch case statement, I can easily go forward and write the cases for what to do when there's an addition, first is subtraction, multiplication, division, and so on. But I really don't know what to do if the value is something other than these four. And because I'm accepting a parameter and the parameter is of type string, it can have any combination of values. It could be A at J, Z A B, it could be any combination of characters and even Unicode characters, as you will see in a later example. So if I'm using switch, I need to cover for those scenarios. And a switch case, as you may recall, needs to be exhaustive. So I will go forward and write my happy cases up front. But once I'm done with the happy cases, Swift will start to give out an error. And let's see that. I'm gonna comment this piece out. I'm gonna switch to automatically run, and you see immediately I get an error saying switch cases must be exhaustive. So it's saying that, okay, what to do if you get another random set of strings? Is a string can have any value, so I add the default case. So all good now. I execute it. The first time I execute it, I'm passing it a bunch of parameters, 3 and 15.7, and passing the operator, which is addition. So all good. 15.7 and 3 makes it 18.7. That's the right answer. I can say it. And for those eagle-eyed wondering why I am assigning to underscore is because I don't intend to do anything with this value. As an example, I want to junk it. And the better way of handling this in Swift, telling the system know that you know and understand the calculator is going to return a value back, which in our case is double. But we don't want to do anything about it. We want to ignore it, is to assign it to underscore. Now, let's say you can assign it some random value. And I here tried to do a roll on the floor emoji. And yes, emojis can be used in Xcode and Swift, and they have valid Unicode characters. So I pass it. But when I pass it, I get -1 because that's the default case. I really did not know what to do with it. Now, that's the problematic scenario because um, passing these two parameters and you getting -1 seems off because you could have passed me 3, 4, and an operator of minus. So the answer -1 would have been valid. How would you know whether the operation got executed successfully and the answer is -1, or really you couldn't handle it because the inputs are wrong? Now, there are a few ways of doing that, and some of you can think of as well. In most programming languages, we have some conditional checks or try catch blocks eventually, where if the condition checks fail, like say it's not in the right set of values, we can throw an exception and catch it. And yes, you can do so in Swift these are called recoverable errors. So this is allowed in Swift, but there is a better way of handling it, and that is by using enumeration. As with the English meaning of enumeration, it's a set of values followed one after the another. But enumeration defines what are the possible limits of the values that it can have. So I go forward to the same example, but this time I go forward and define an arithmetic enumeration. And I'm going to go forward and have it configured to be automatically run. Awesome. Now I defined an arithmetic operation here, and the arithmetic operation has an enumeration of four different values. And the four values are plus, minus, multiply, and division. It cannot have any other value because it's restricting the possible choices. Now I go to my calculate function and let's see what changes we made. The first parameter still is a double, second parameter still a double, but the third parameter, which was using operator, has now changed to be of type enumeration. Now, because it's of type enumeration, Swift is smart enough to realize that it can have only finite set of values, and that in the switch case, I'm covering all the finite set of values. I'm covering the scenario for plus, and you execute or you get to the values of the enumeration with the dot operator. Ideally speaking, you can have something like arithmetic operation dot plus, okay, which is valid as you say, it's fine, no errors at all. But in Swift, Swift is smart, so it's context sensitive. So it knows the operator on which you're switching is an enumeration. So the values must be one of its types. So you don't need to write arithmetic operation in front of each and every case. You can just start with the dot value and list down the possible choices. And there are plus, minus, multiply, and division. Now, Swift also understands that you have exhausted all the possible lists of choices, so you do not need a default statement like you did when you were using a string, because string could have multiple or a large set of possibilities. But you have exhausted all the possible values inside an enumeration. So Swift is happy. Now let's see how you call it. While calling it, you simply go forward and say calculate first parameter, second parameter, and the operator you specify that it is multiply, and you go forward and run it. You're going to get the value on execution, which is 47.09. All good here. Now let's see, what if you tried and bypass those possible values? First of all, well, if you go in here and you try and bypass the value by typing arithmetic operation dot, well, you can't really type a random value because that's something which is not known, or you have not defined it as part of the enumeration. So that's not possible. The only set of values which are possible are the ones which you have defined. So it restricts the choices, and Swift knows it and autofills for you. You can try and bypass it completely and pass it some random string, but now it's a compilation error because the function accepts the enumeration, not a string. So that's not going to match, and a compilation error is going to result. So that's where you end up using enumeration, where you want to restrict the possible set of choices. Here I was trying to restrict the possible set of choices for strings, but it's totally valid for you to go forward and try and restrict any possible set of choices, whether you're switching for integers. Very well could have been integers, and you could might be accepting only first three integers, 1, 2, and 3, and everything else could be invalid. And if you switch for integer type, any number is possible. So with enumeration, you can still go forward and restrict those. Now with the example which I provided with emojis, let's see if that one was possible. If I could have gone forward and defined an enumeration for emoji and returned some value. Now, in my hypothetical example again, I'm going to start accepting emoji. If you return me emoji, I'm just going to return 999. Does not make any sense, but it's to show that any Unicode value is accepted. And emojis are Unicode, so they are acceptable choices. You can have a smiley face, sad face, and that could result in choices like you ask a person how my mood is, and based upon the case statement or the choice which you pass for the enumeration, you can tell them that, okay, you are feeling happy, you're feeling sad, and so on. And that's totally doable. In the arithmetic operation, I go forward and add the case for my emoji. And then I go forward and add the case inside the switch statement. If I did not had that case, and I'm going to configure it to run automatically, you see it, you get an error because it now knows the enumeration has one more possible value. So I add it back. And while calling, you call it exactly like you call in either case. For multiply, you were calling dot multiply. For emoji, you simply go forward and call dot and with the emoji, and that's pretty much it. And you're done. Okay, now that's pretty cool. We can actually restrict the possible set of choices, which can come very handy for switch case statements. So all good and dandy. The Is there anything else that we can do with enums? Now, enums in Swift are very powerful as compared to other languages. And if you have experience of enums in other programming languages, again, the standard ones like C++, Java, then you will be pleasantly surprised by how powerful enumerations are in Swift. And I'm not going to go into all possible details, combinations on how to add behavior and other items in enumeration, but I'm going to cover two important aspects of enumeration. Here, I was using enumeration to just restrict the type of values it can have. But now I'm gonna go forward and assign some raw values to my enumerations. So let's look at it. Here, what I'm doing is that I'm defining my enumeration like I had defined earlier, but I have gone forward and defined and done a type annotation to indicate the type of the raw value I'm going to use. And here I'm going to use the raw values which are of type string. As you would have guessed, the raw values are possible for all possible types. You can use for double, integer, float, strings, any value you like. All you have to do is that when you define the case statements, you go forward and define the cases, plus at the same point in time, assign them their raw values. Here, plus is being assigned as a raw value of plus, minus, minus, multiply, multiply, division, division, and so on. So each one of them have a raw value which is available now. In my calculate function here, I did not make any change because I'm trying to highlight the fact that even if you assign raw values, it does not mean that the way you handle individual cases changes a bit. The way you handle individual cases remains BAU. And that's what is being highlighted here. You will do your enumeration checks, but which is restricting the values as BAU. You go forward and you now have a calculate function, which is still accepting the operator just as BAU. Instead of ignoring the result, I'm capturing the result. And what I'm doing is that I'm trying to print what the user did. The user took the two operands and ran operation like addition, subtraction, multiplication, division, or what exactly the user did. And I want to print the value instead of me putting in another if else condition to see what operation was for printing purposes. Now I can simply say first parameter operation dot raw value, because raw value is the right symbol which is present, and then the second parameter and show the result as the calculation would have occurred. So let's go forward, configure it to automatically run, and let's hit it. When it runs, you see that it goes forward, not only executes it, but it also prints it on what operation it was trying to perform. Let's go forward, and since it's a variable type, I am going to do another round of operations here. And this time around, I am going to go for, I don't need to define the calculated result again. It was a variable. I don't need to define first parameter, second parameter again. They were also the variables. So I can drop the var keywords in front of them, and I can simply go forward and change the value. So this time I'm going to take 10 and I'm going to use 2. And instead of multiply, I am going to go with division. Okay. So now it's asking what operations were actually performed, and operation which was done is listed here. So let's go forward and define what the operation was done one more time, like we did for others. So operation is going to be dot division. Okay, so I did that, and actually you can simply pass operation instead of passing it, because it's of the same type. Instead of passing it arithmetic operation dot division, you can definitely pass the operation to it, and see it goes forward and computes and prints nicely the operation which I was trying to do. For all of you who are worried about why 10 divided by 2 would result in 0.199 and instead of number like 5, which is probably what you were expecting, You probably need to see my course on my section on the data types. That will provide you more clarity on what exactly happened here. Moving on, here next, let's move on to raw values. Again, a different example, just like raw values, which we had example of string. I'm now going to have example for integers, just to show that different data types are actually possible. And this time, all I'm doing is I'm printing the size of the memory that you have. So I have memory units, and for each memory unit, whether it's byte, kilobyte, megabyte, gigabyte, I have went forward and assigned the raw values of how many bytes that megabyte actually represents. And then there's a function which just returns the size in bytes and takes your memory unit and then memory size and then the memory units and just multiplies them and tells you that what the final value is in bytes. All it does is takes your memory size, which is integer, you pass it along, and the memory units, whether it was megabyte, gigabyte, or kilobyte, and gets its raw value, and you get the result. Here I go forward and say I have 10 gigabyte of memory, and the memory unit is gigabyte. I pass the information along, I execute it, and I will get back the number of bytes, which is a big string, but this is the number of bytes that I actually have. And remember, a gigabyte or a kilobyte is not 1024, so it will be off than just one followed by a lot of zeros. All good and done, and I hope by now you are very clear on how raw values actually work. Now we are going to move on to associated values. We got the raw values and it made sense. And some people see this and say that, oh, that seems like a way of introducing a map which has a restricted set of keys, which is defined by cases. And then each one has values. So it's a way of implementing a map. Conceptually you can think of it in that manner, but I would not recommend using enumerations for a map purpose. They're not going to be efficient. You don't have all the operations which are available on maps, like getting the values or checking whether a map contains a particular key. So those operations will not be really valid. So I would not recommend it. And again, the animation is defined upfront. So you will have to list on all the possible keys and it will not grow or shrink. So definitely not recommended. Use maps wherever you really want to use maps. The last piece I want to cover about enumerations is the associated values. The difference between raw values and the associated values is that raw values go forward and restrict the data type of the value associated with your enumeration cases. Here I had plus minus division and multiplication, but for all those cases, I could go forward and assign a different value, but the value must be of type string because I defined it of type string. I cannot go forward and change the value for each and every case. Associated value provides you that flexibility. You can define your enumeration instead of defining your data type at the top. You can go forward and define for each case what's the data type of the associated value for that particular case. And in this example, I have gone forward and defined an enumeration which defines an actor. It has a cases whether you're trying to talk about the age, full name, net worth of the actor, and then it goes forward and has a function which will for a particular enumeration value pass will print you the details regarding the same. So I go forward and define and instantiate three different variables for the same enumeration actor and go forward and assign it the value of three different cases. The first one is age and define the age. Second is net worth, third is the full name. And then go forward and just call the function to print the values. And let's see what happens when I run it. Now, when I execute it, I'm able to get all the associated values with those actors, and I can see one is integer, one is string, one is double, so it varies. And I can now assign a different value to each and every case. So it gives me even more powerful. And as we would have seen, enumerations are very, very powerful in Swift, and they provide a mechanism where you can just go forward and restrict the possible set of choices you have available. So it helps with your switch case statements. You can go forward and assign it the raw values so that you have some association going on there with the raw values that can be used for later printing or just telling what the value is. For example, You may have an enumeration which has a case for pi, and the value of the pi is stored in the enumeration of 3.14 if someone really wants to know what their raw value is or what the meaning of that case is. Then you have associated values, and associated values allow you to even go further and for each case assign a different data type. So all good up till now. Now, some people come to me and say that, okay, now with the enumeration, which is having the cases with associated values, so different data types, isn't it becoming more and more like a struct or a class? And yes, it is becoming more and more like a struct and class, and that's why I said enumeration is very powerful. But there's a reason and purpose behind anything that we are doing. Enumeration's basic purpose is to restrict the possible set of choices. Um, and that's where I think this should be used. If you really want to define your own data types, I think you should go with structs if you do not have a need for anyone to go forward and add new storage variables. But if you have a need to allow folks to inherit and define their own storage variables, then you should go forward with classes rather than structs. And that's pretty much all I wanted to cover about enumerations. Like I said, there is a lot more that enumerations can support us, so if they are very powerful, but I will let you handle the extreme or the more complicated scenarios by going over the developer documents at Apple. Thank you.